Endocrine glands are ductless glands of the endocrine system that secrete their products, hormones, directly into the blood. The major glands of the endocrine system include the pineal gland, pituitary gland, pancreas, ovaries, testicles, thyroid gland, parathyroid gland, hypothalamus and adrenal glands. The hypothalamus and pituitary glands are neuroendocrine organs. Pituitary gland. The pituitary gland hangs from the base of the brain by the pituitary stalk, and is enclosed by bone. It consists of a hormone-producing glandular portion of the anterior pituitary and a neural portion of the posterior pituitary, which is an extension of the hypothalamus. The hypothalamus regulates the hormonal output of the anterior pituitary and creates two hormones that it exports to the posterior pituitary for storage and later release. 4 of the 6 anterior pituitary hormones are tropic hormones that regulate the function of other endocrine organs. Most anterior pituitary hormones exhibit a diurnal rhythm of release, which is subject to modification by stimuli influencing the hypothalamus. Somatotropic hormone or growth hormone, GH, is an anabolic hormone that stimulates the growth of all body tissues, especially skeletal muscle and bone. Hypersecretion causes gigantism in children and acromegaly in adults. Hyposecretion in children causes pituitary dwarfism. Thyroid-stimulating hormone promotes normal development and activity of the thyroid gland. Thyrotrophin-releasing hormone stimulates its release. Negative feedback of thyroid hormone inhibits it. Adrenocorticotropic hormone stimulates the adrenal cortex to release corticosteroids. Adrenocorticotropic hormone release is triggered by corticotropin-releasing hormone and inhibited by rising glucocorticoid levels. The gonadotropins, follicle-stimulating hormone and luteinizing hormone regulate the functions of the gonads in both sexes. Follicle-stimulating hormone stimulates sex cell production, luteinizing hormone stimulates gonadal hormone production. Gonadotropin levels rise in response to gonadotropin-releasing hormone. Negative feedback of gonadal hormones inhibits gonadotropin release. Prolactin promotes milk production in human females. Its secretion is prompted by prolactin-releasing hormone and inhibited by prolactin-inhibiting hormone. The intermediate lobe of the pituitary gland secretes only one enzyme that is melanocyte-stimulating hormone. It is linked with the formation of the black pigment in our skin called melanin. The neurohypophysis stores and releases 2 hypothalamic hormones. Oxytocin stimulates powerful uterine contractions, which trigger labor and delivery of an infant, and milk ejection in nursing women. Its release is mediated reflexively by the hypothalamus and represents a positive feedback mechanism. Antidiuretic hormone stimulates the kidney tubules to reabsorb and conserve water, resulting in small volumes of highly concentrated urine and decreased plasma osmolality. Antidiuretic hormone is released in response to high solute concentrations in the blood and inhibited by low solute concentrations in the blood. Hyposecretion results in diabetes insipidus. Thyroid gland. The thyroid gland is located in the front of the neck, in front of the thyroid cartilage, and is shaped like a butterfly, with 2 wings connected by a central isthmus. Thyroid tissue consists of follicles with a stored protein called colloid, containing thyroglobulin, a precursor to other thyroid hormones, which are manufactured within the colloid. The thyroid hormones increase the rate of cellular metabolism, and include thyroxine, T4, and triiodothyronine, T3. Secretion is stimulated by the thyroid-stimulating hormone, secreted by the anterior pituitary. When thyroid levels are high, there is negative feedback that decreases the amount of thyroid-stimulating hormone secreted. Most T4 is converted to T3, a more active form, in the target tissues. Calcitonin, produced by the parafollicular cells, C cells, of the thyroid gland in response to rising blood calcium levels, depresses blood calcium levels by inhibiting bone matrix resorption and enhancing calcium deposit in bones. Excessive secretion cause hyperthyroidism and deficiency cause hypothyroidism. Parathyroid glands. The parathyroid glands, of which there are 4 to 6, are found on the back of the thyroid glands, and secrete parathyroid hormone. 2. This causes an increase in blood calcium levels by targeting bone, the intestine, and the kidneys. The parathyroid hormone is the antagonist of calcitonin. Parathyroid hormone release is triggered by falling blood calcium levels and is inhibited by rising blood calcium levels. Adrenal glands. The adrenal glands are located above the kidneys in humans and in front of the kidneys in other animals. The adrenal glands produce a variety of hormones including adrenaline and the steroids aldosterone, cortisol, and dehydroepiandrosterone sulfate DHEA. 3. Adrenaline increases blood pressure, heart rate, and metabolism in reaction to stress. The aldosterone controls the body's salt and water balance, the cortisol plays a role in stress response, and the dehydroepiandrosterone sulfate DHEA produces aids in production of body odor and growth of body hair during puberty. Pancreas. The pancreas, located in the abdomen, below and behind the stomach, is both an exocrine and an endocrine gland. The alpha and beta cells are the endocrine cells in the pancreatic islets that release insulin and glucagon and smaller amounts of other hormones into the blood. Insulin and glucagon influence blood sugar levels. Glucagon is released and the blood glucose level is low and stimulates the liver to release glucose into the blood. Insulin increases the rate of glucose uptake and metabolism by most body cells. Somatostatin is released by delta cells and acts as an inhibitor of GH, insulin, and glucagon. Gonads. The ovaries of the female, located in the pelvic cavity, release two main hormones. Secretion of estrogens by the ovarian follicles begins at puberty under the influence of follicle-stimulating hormone. Estrogens stimulate the maturation of the female reproductive system and the development of secondary sexual characteristics. Progesterone is released in response to high blood levels of luteinizing hormone. It works with estrogens in establishing the menstrual cycle. The testes of the male begin to produce testosterone at puberty in response to luteinizing hormone. Testosterone promotes maturation of the male reproductive organs, development of secondary sex characteristics such as increased muscle and bone mass, and the growth of body hair. Pineal gland. The pineal gland is located in the diencephalon of the brain. It primarily releases melatonin, which influences daily rhythms and may have an antagonotropic effect in humans. Citation needed. It may also influence the melanotropes and melanocytes located in the skin.